We're covering lesson 211, which is chapter 10 in our electrical systems book. Subject is equipment for general use. We're going to hit some things like light fixtures, cords, receptacles. So again, general use equipment, just as the name implies here, right? So jumping right in, flexible cords and cables shall be marked. Okay, we all know this from looking at you think about Romex or any type of cord you've ever used. Of course, you can never find the info you need on the length of the cable you're looking at that moment, but it should have, among other things, we need to have voltage rating, we need to have insulation type, we need to have information from the manufacturer. Again, usually you're looking at that for voltage rating and for, I don't think I mentioned, but actual wire size as well. Branch circuit overcurrent protection devices are permitted to provide overcurrent protection for flexible cords and cables. To do that, we're actually referencing a couple tables in our NEC, the first of which is 400.5A1, and I'll flip back to this here, but then the second is 400.5A2. So big thing to notice here is you have your conductor size over here. You have all these different cable types or cord types, I should say. And now here we're dealing with column A and column B on this table. Column A apply to 3 conductor cords where only 3 conductors are current carrying. Column B is for when there's only 2 conductors that are current carrying. Similarly, on the next table, we have a column D, E, and F, and they give us some more info here on D, E, and F. It gets kind of wordy and specific, but be sure to just check that out and be aware of which column you should be in any given case, right? So we have 11 uses specifically permitted for flexible cords and cables. Many of these should not be a surprise. Pendant luminaires, essentially anything that's portable, right? And that gets to this kind of equipment. We've got shop equipment. We've got anything with moving parts that need to connect is a big one. I don't think many of us are going to fall under this sort of section here, but appliances, that's a big one. So your ranges, your dishwashers, anything with vibration or noise, right, that would, if a rigid connection would vibrate loose, we're okay to use flexible cords. Now, I think more importantly, though, is some uses specifically not permitted, right? So it can't be a substitute for building wiring. That's the biggest one. You don't use this and run it through or inside or on the surface of a building. We should be using conduit. We should be using MC cable, a Romex cable, whatever the appropriate use is. I think most of these are very obvious. However, once you start pulling a cord into a raceway or pulling it through studs or concealed or attaching it to the building surface, you're probably doing something wrong at that point, right? So flexible cords and flexible cables shall be connected to devices and fittings to ensure tension is not transmitted to the joints or terminals. So we don't want to compromise our wiring connection. We need some kind of a strain relief device or connector. Probably the most common, and I think one of the more neat devices we get to use here is this type of a strain relief connector. A lot of guys would call this kind of like your Chinese finger trap. If you've ever seen one of those cheap toys from the fair, it works exactly the same way. You can sort of push the wire in, but as you pull out, the basket weave kind of gets tighter and actually holds that cable in there. It does a great job of it. This is not the only type, but this is probably one of the most common types. I think the sort of the most effective, easy to use. Cord connected fixtures, hanging fixtures, lighting track pendants, so on and so forth cannot be installed in the bathtub zone, which you hopefully remember is 3 foot horizontally. So this is like you're looking at an overhead view. And then 8 foot vertically, so we're looking at a side-on view. 8 foot vertically from the edge of the tub or basin or shower, whatever we have. Right. Pendants and incandescent luminaires with open or partially enclosed lamps are not permitted to be installed in closed closets. Again, hopefully you remember this well from year 1 as well. But if we have surface-mounted or recessed fluorescent, enclosed recessed incandescent fixtures or LED, we need to be at least 6 inches. Where it is enclosed surface-mounted incandescent fixture or LED, we need to be 12 inches. And there's just no surface-mounted incandescent or pendants in the closets whatsoever. And the NEC actually uses this diagram, which I think is pretty nice as well. But you'll find that in your your NEC. 410.2 is this image. Here's one, I've frankly never seen it, but I think it's worth mentioning anyway. But handholds are not required in 20-foot or less metal poles that support luminaires or lighting fixtures if the base is hinged. So we can actually hinge the whole thing down. I've never actually seen a hinged pole base. Maybe you guys have, but anyway, there you have it, right? Lay-in type luminaires should be securely fastened to the ceiling. This is one I'm sure by now has been beat into your head. We've got to actually fasten it to the grid. They don't mention we actually have to, in our area at least, have to fasten it to the structure as well using some tie wires. But we've got to support it and actually fasten it to the grid as well. A lot of times you guys are probably just using these bend out, hook tabs as they call them. This one I always like to mention because it still surprises me every time. But trees are permitted to support outdoor lighting fixtures and their associated equipment. However, we can't use this tree as an overhead. If we ran a cable from here out to the light, we can't do that. Right? That's a violation. But we can actually mount a light to the tree, believe it or not. Right? Lamp holders and luminaires may be connected with flexible cord. Here, I think the images kind of show you everything you really need to see here on this stuff. Thermally protected luminaires provide additional safety measures by ensuring that overheated luminaires do not provide a source of ignition for combustible materials. So, the first thing that should be said is we have IC rated and non-IC rated recess fixtures. IC means it's rated for insulation contact or to be in an insulated ceiling. Non-IC means the opposite. We must have at least 3 inches separation between the insulation and our light fixture. Furthermore on this, you might actually, if you've ever seen a device like this and you wonder, maybe you don't know what it is, maybe you do. It's actually a thermal protector for a light fixture. So what will happen is if that thing gets hot, we actually run our circuit through these wire leads here, and just if it gets hot, this thing will actually open up, breaking the connection, shutting the light off. Once it cools down, once the light's been off, it'll actually close again and reignite the light. So if you ever get that service call of a fixture that's sort of blinking on and off intermittently, odds are it's overheating for some reason, and there's a thermal protector. So the thing not to do naturally is just kind of bypass that and get rid of it. It's overheating. We need to find the cause of the overheating. Is it an overlapping issue? Is it a fixture that's in insulation that's not rated to be? Whatever the case, there's your thermal protector. Right? All recessed high-intensity discharge luminaires shall be thermally protected. So there's what we just mentioned. Tap conductors are used to connect branch circuit wiring to the fixture wiring. They give us some specifics here, right? So they're going to tell us an outlet box can be installed at a point which is at least 1 foot from the luminaire, and then tap conductors can be installed from there. So we must be at least, the box needs to be at least 1 foot away. They tell us here the raceway or cable that feeds the light must be a minimum of 18 inches in length, but not greater than 6 foot. The 1 foot spacing of the outlet box ensures that the heat generated in luminaire does not affect the wiring. Again, I think most of you guys are familiar with the 6 foot fixture whips. That's written into a lot of specs anyway. Lighting track consists of a length of energized track and luminaire that can be positioned anywhere on the track. I think we all know what that is at this point, but I did want to mention that the NEC, specifically 220.43b, requires that each 2 foot of lighting track be considered as 150 volt amps for the purposes of determining load calculation. So every 2 foot of track counts as 150 volt amps in your load calculations. All receptacles are classified as standard receptacles or special use receptacles. Here we have some examples of some various receptacles, honestly. So we kind of have a standard here. This is a non-grounding type receptacle. Notice we don't have the third prong for the ground. The orange triangle, as a reminder, is for your isolated ground. This green dot is hospital grade, essentially, heavy duty grade. GFCI right here could be an AFCI, I guess, too. And then tamper resistant doesn't look a lot different in a picture, but I think by now everybody's seen tamper resistant. It's got the shutters where you got to put the hot and neutral in at the same time, right? So isolated ground receptacle, let's talk about that guy a little bit. Again, if you see the orange triangle or any triangle, honestly, tells us it's an isolated ground. Essentially what that means is we're going to have one ground that goes essentially straight from our ground bus bar all the way out to the ground on the receptacle, and we're not using that ground to ground our raceways and our boxes and things like that. It's isolated specifically for the terminal on these isolated ground receptacles. We're going to have a second ground, or maybe just use the raceway as the ground for our metal, our non-current carrying parts, our raceways, our enclosures, our conduits, things like that. Right. So essentially, you're running two grounds out to all these, unless you're going to try to argue that you're going to use your raceway as your equipment ground. Again, we're not really seeing that nowadays as much. Three methods are permitted for the install of replacement receptacles when grounding does not exist. It's a good one. Again, in year one, I know you guys hit it pretty hard, but essentially you got the old two-prong outlets. We don't want that. We want to have a grounding outlet. We want the three-prong outlet. So your first option is to replace it with another two-prong, another non-grounding. Well, that seems like a waste of time. Second option, replace this receptacle directly one-for-one with the GFCI. Now you're going to have to put the label on there that says no equipment ground. And then your third option, and your best one if you can get away with it, is put a three-prong in with no ground as long as it's fed or supplied by a GFCI device. And again, we're going to put no equipment ground, and we're going to put GFCI protected, that little pack of stickers that everybody probably throws away with the GFI, right? I always thought about this. You could essentially put a GFCI breaker, or even find the home run out of the panel and just cut a GFCI receptacle in line. That way you don't have to worry about how they ran the circuit around the room, especially if it's an older circuitry. It might be a little haphazard. But it essentially make it GFCI protected, and we can start replacing the two prongs with three prongs, right? Single screws are not permitted to secure receptacles to raised covers. Usually you'll see so your raised cover, you're going to see the little thing in here that you kind of break out. That's actually kind of like a nut for your screws here, your device screws 1 and 2. So you're going to break those out and use it as the nut on the back of the plate. You can still feel free to put your third screw in there, but it is not permitted to only use this middle screw. It is easy and tempting, but it is a code violation, and I have seen guys fail for that. So you got to have at least 2 screws securing your device, 406.5C. Kitchen, in-sink, food waste disposers, trash compactors, and dishwashers are permitted to be cord and plug connected. Back to the beginning, we mentioned we can use cords for these, so-called portable appliances. I know, a range, a dishwasher, a garbage disposal was not really considered portable, but we do need to move it in and out for servicing. So we're fine to do cord and plug connections for these guys. Ceiling fans weighing over 35 pounds shall not be supported by the outlet box. We have to support it independently somehow, whether that's somehow above, some kind of bracing, something. The fan's going to have to be connected directly to the structure in some way. In this case, they have a 3/8 bolt rod. That's a fine way to do it here. And then they even go so far as to mention outlet boxes or systems used as the sole support of ceiling fans shall be listed and marked, and shall not support fans that weigh more than 70 pounds. Right. So if you get a fan over 70 pounds, you're definitely supporting that thing independently. That's a monster fan for sure. So there again, a wide variety of info, but I think some general use stuff that everybody's seeing every day, everybody's used to dealing with. So again, lesson 211.